Hello, Algebra 2. Welcome to the 5.7 video, the Binomial Theorem. Our goal today is to expand a binomial using Pascal's triangle and using the Binomial Theorem. So we're going to look at patterns of what happens when you raise a binomial to a power and then rewrite that in standard form. So a couple of key vocab words. Binomial is a two-term polynomial. Then we're going to raise that to a power, that's the exponent, and then look at patterns of how it relates to Pascal's triangle. So first, to expand a binomial is when we rewrite the binomial raised to a power in standard form. So we're going to take a binomial, raise it to a power, whether it be 3, 4, 5, and then multiply out those binomials and start to look at the pattern. The pattern that is created is called Pascal's triangle. It's an array of numbers in which the first and last number in each row is 1, and then each number in the row is the sum of the two numbers above it. So as we look at the pattern, we have a 1, and then we have a 1, 1, and then we have 1, 2, 1, where the 2 is the result of the two numbers above adding together to make 2. Then we have 1, 3, 3, 1, where the result is the 2 and the 1 adding together to make 3, and here the 2 and the 1 adding together to make 3. And it continues that pattern for as long as you'd want to go. So when you start to multiply out binomials, we can see the pattern of Pascal's triangle start to come to life. So first, on the left side here, I named the rows. So these are the row of the Pascal's triangle. So the first, or the very top row is called your row 0, and this would be called row 1, row 2, row 3, so on. And the row will match up to the power that you are multiplying out your binomial. So a plus b to the 0 power, well, anything raised to the 0 power is just a 1. A plus b to the first power, if you look at your coefficients, those are going to match up to Pascal's triangle. So those both have a coefficient of 1, and then that's what we're seeing right here. Both have coefficients of 1. Now when I get to row 2 here, where I'm going to multiply out a plus b squared, now just keep in mind that's going to be a plus b times a plus b. You end up getting a squared plus 2ab plus b squared. And if you look embedded inside the answer, you'll have a 1, 2, 1, which is the next row of Pascal's triangle. And then if we multiply out a plus b 3 times, that would be a plus b times a plus b times a plus b. So I'd have to use a FOIL method, and then I would also have to use a distributive property method to multiply all those out. But that would end up giving me a to the third plus 3a squared b plus 3ab squared plus 1. And if you notice, the coefficients 1, 3, 3, 1 also match up to Pascal's triangle, 1, 3, 3, 1. So if I did a plus b to the fourth, that's going to be a to the fourth plus 4a to the third b plus 6a squared b squared plus 4a to the a times b to the third plus b to the fourth. So that would be that next row if we use that binomial theorem. So when we start to raise a binomial to a power, we can start to see the pattern of what the coefficients are going to multiply out to in the problem. So we're going to practice one with raising to a power of 4. So we'll grab the Pascal's numbers and then start to break it down into multiplying it out to a polynomial in standard form. So in this problem, we want to expand x plus 3 to the fourth. So first we're going to use the fourth. That's going to mean that we're using the fourth row of Pascal's triangle. And that's going to be then where we had the 1, 4, 6, 4, 1. So that second number in, that's going to match your power that you're using. Next, you want to identify your A and your B. So here we're going to have an A that's equal to x, and then a B that's equal to 3. And then we can use that A and that B when we start to organize our powers as we multiply it out. So the pattern is then your Pascal's number is going to be the coefficient of your first term is going to match up to the first number of your Pascal's row there. So we're going to have 1. Then you take your a power and you raise it to the 4th. So that's going to be x to the 4th. And then technically, your 3 would be raised to the 0 power. So there would be your first term of this binomial expanded. So you got your Pascal's number, you're raising x to the 4th, and then your 3 is to the 0. You're always going to make sure your two exponents add back up to 4. So we're going to see that pattern happening here as we go. Then continuing, we're going to have a plus. Then we go to the next Pascal's number, which is 4. And then we're going to have x to the 3rd. And then we're going to also raise 3 to the 1st. And I should be putting these into parentheses in case they were negative so that we are multiplying those out correctly. So let's make sure we do that too. So there is our next term. Then we continue with the next Pascal's number plus, we're going to have 6. And then we'll have the x to the 2nd. Making sure we put that in parentheses so it's all going to be squared out correctly, 3 to the 2nd. And then next Pascal's number would be 4. And then our two a and our b, so our x would be raised to the 1st, and then our b would be raised to the 3rd. And just noticing as I'm going through the pattern, every time my exponents are adding back to 4. They should always add back to whatever power I'm raising to. And then finish up, our last Pascal's number is a 1. And then that would be x to the 0 power and 3 to the 4th power. All right, now we're ready to simplify. So now we're just going to look at each term and start to simplify it out. So this would be 1 times x to the 4th, and then anything raised to the 0 power is 1. So that would just all simplify to x to the 4th. Then 4 times x to the 3rd times 3. Well, the 4 and the 3 are going to multiply to 12. So that'd be 12 x to the 3rd. And then 6 times x squared times 3 squared. That's going to be 6 times 9, which is 54 x squared. And then 4 times x to the 1st times 3 to the 3rd. 3 to the 3rd is 3 times 3 times 3, which is 27. 27 times 4 is 108. So that'd be 108x. And then 1 times x to the 0. X to the 0 is 1. So anything raised to a 0 power is 1. And then 3 to the 4th. That's going to be 3 times 3 times 3, which is 27, times another 3, which is 81. So 1 times 81 is still just 81. So there would now be my polynomial in standard form. So there would be all my terms. And I'm following that pattern of Pascal's triangle, plus I'm following the pattern of how those a and b powers are always adding up to 4. And as the x is decreasing, your other power is increasing. So here in problem 2, I already took the Pascal's number. So I went to row 3, grabbed the 1, 3, 3, 1, and then also found my a value and found my b value. So now my b value is negative z because it's 3 minus z. So I do have to be careful, make sure anytime we're raising z to a power, we're putting it in parentheses so we correctly put z, that negative power, to the correct exponent. So heading down, then we'll grab the first Pascal's number, which is 1. Then we'll take the a, which is 3. And I wanted to make that red. So a is 3, so we'll go 3. And then raise it to the 3rd power. And then negative z is raised to the 0 power. So I put a little line through my z's there. So that's a z. And then continuing, the next Pascal's number is going to be 3. And then then we'll grab our a, which is 3, and now we'll raise that to the 2nd power. And then negative z raised to the 1st power. And then continue, grab the Pascal's number, 3. and continue following that pattern. So the last two terms, we followed that pattern. We'd have 3 to the first, z to the second, and always making sure they add up to 3, 3 to the 0, negative z to the third. Now we're ready to simplify. So now we'll take a look at this first term. So I'm going to have a 1 times 3 to the third. Well, 3 to the third is 27. And then anything raised to the 0 power is 1. So my first term is just simply 27. And then I'm going to hold off on writing the plus sign because I don't know this next term. I've got a negative in it. So if it's negative, I'm just going to use a subtraction sign. So heading to here, we're going to have 3 times 3 squared, which is 27. And then negative z to the first is negative z. So this would end up being 27 times negative z. So 27 times negative z, which would be negative 27z. So I got to make sure I'm following all of those rules with multiplying and positives and negatives to get my term correct. Okay, so then we're going to head into 3 times 3 to the first would be 9, and then that negative z squared, so that would have been a negative. Looks like my negative disappeared. Negative z squared would be negative z times negative z, which would be positive. So that's going to be a plus 9z squared. And then lastly, I'm going to have a 1 times 3 to the 0 times negative z to the third. Well, 1 times 1, that's what these two are going to make, which is still 1. And then negative z to the third would be negative z times negative z times negative z, which is negative z to the third power. So when I multiply negative z times negative z, it's back to positive. But then that third negative z changes it back to negative. Anytime you see you have this minus sign in here, you're going to see that it's going to alternate between plus and minus in your terms. So it's going to alternate positive 27, negative 27z, positive 9z squared, negative z to the third. So we'll see that alternating, that plus minus. All right, let's take a look at our last problem. This will relate more to our practice assignment. So lastly, we're going to look, what is the fifth term of the expansion a plus b to the eighth in simplest form? And that just means to multiply out anything that's possible. So we'll go to Pascal's triangle, we'll grab that eighth row, and then we'll also start to talk about how we can just find that fifth term. So right now you're going to go back to Pascal's triangle, find the eighth row. All right, so the eighth row of Pascal's triangle would be a 1, 8, 28, 56, 70, 56, 28, 8, 1. And there should be 9 total numbers. So whatever row you're on, you always have one more total term. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're good. So then this one would be term number 1. This would be term 2. This would be term 3, 4, 5. So this is the one we're looking for. That's the term 5. The last thing we have to do is look at the pattern that happens with A and B. So just remember from above, the pattern is your A is going to be raised to the full 8th power, and at this first term, your B is going to be raised to 0. At this term, your A is raised to 7, B is raised to 1. This one, your A is raised to 6, B is raised to 2. This one, A is raised to 5, B is raised to 3. And then the fifth term, which we want, A is raised to 4, B is raised to 4. So now these two are going to be what makes up that fifth term. So we're going to grab the Pascal's number, which is 70, and then we grab the pattern of the powers, which is a to the fourth, b to the fourth. So there would be my fifth term of my polynomial. So all in all, we're going to use Pascal's triangle to help us with those coefficients, and then we can follow that power pattern as we multiply out these binomials to get our powers organized. So you're ready to practice 5.7. You can go ahead and good luck, and we'll see you next time.